Hey everybody, welcome to semester 2, day 6 of summer school geometry. Today we're going to be talking all about how the linear dimensions of a shape affect its surface area. Now the surface area is, if you think about any object, a three-dimensional object, and you look at all of its sides and you add up those areas, that's called the surface area because you're looking at what's on the surface of that object. So let's just start with this basic example right here. It's a rectangular prism. So back in middle school, you might have learned that the area of a rectangle is length times width, or you could think of the length, the area of a rectangle is base times height. So what we're trying to do in this first example is determine what the surface area of this object is. Now, if I look at it from all the different directions, like from the right side, I would see this red face. And that red face has a dimension of 6 kilometers by 4 kilometers. So if I think about that side right there, the area is equal to 6 times 4, which is equal to 24. And that would be the same thing as the area on the left side of the box as well, because the right and the left side of the box are the same. So 24, and you would have a 24 on this side as well. Then if I think about on the top, what are the dimensions of that rectangle on the top? Well, I see on the bottom it's 3 by 4, and that's the same thing up here, 3 right here in the front and 4 over here. So that area would be 3 times 4, which is equal to 12, and that's going to be the same thing on the bottom. We would have 12. And now in the front, pointing at the front of it, we have 3, and then this length right here is the same as this length back here. It's the same height, so it's 6. So this area would be 3 times 6, and that's kind of hard to see. This area in the front would be 3 times 6, which is 18. So that means in the back, you'd also get 18. So now I'm going to circle all of those areas. We got 12 on the top, 12 on the bottom, 24 on the right, 24 on the left, 24 in the back, and 18 in the back, and 18 in front. So now to figure out the surface area, usually it's abbreviated SA, surface area. It's going to be all of those sides added up together. So I can just list them all out, 12 plus 12, 24 plus 24, and 18 plus 18, or you could do 2 times 12, 2 times 24, and 2 times 18 like that. So here we have 24, 48, 36. We keep on adding those up. If I do 24 plus 36, that's going to get me 60. 60 plus 48 is equal to 108. So in total, the surface area is 108. Okay. So that's how you figure out the surface area. We could do that with different objects as well. For example, right here, let's find the surface area of a square pyramid. A pyramid has a square as its base. Okay, it has a side length of 3 yards and 3 yards this way since it's a square on the bottom, and a slant height. That means if you were to measure from the tip of the pyramid down to the base along the triangle, it would be a total of 4 yards. So now I need to think, what you can sometimes do is draw a net. A net means you would flatten out all the sides into one even field. If I were to think about the net, I would have a square down here, and each edge of the square is the base of a triangle. So that means if I were to create the net, I would have the triangle going out this way in all 4 directions. If I were to flatten out, if I were to cut the pyramid open at each of these edges and flatten out the sides, this is what it would look like. That's the net. And now I just think about the dimensions. I got 3 by 3 there. Now the height of the triangle, they said was 4. If I think about the area of a triangle, it's equal to 1/2 base times height, which is, in this case, 1/2 3 times 4, which is equal to 12 divided by 2, which is equal to 6. So each one of these is 6. And then the inner square right here is 3 times 3, which is 9. So now I just add all of those up. The surface area is equal to 6 added up 4 times for all 4 triangles. 1, 2, 3, 4, and then the square, so plus 9. So this is 24 plus 9 is going to end up being 33. Okay, then let's talk about this next one. This is a cylinder. To figure out the surface area of a cylinder, I need to think about what is the net of that cylinder, or what are the faces that compose the cylinder. So on the top, I have a circle, area equals pi r squared. And I have that same thing on the bottom, area equals pi r squared. But then I need to think about, what about this face right here, the sides of this cylinder? Well, if I were to unroll this cylinder and flatten out this portion of the cylinder, I would get a rectangle. So I'm thinking about this guy right here. And if I were to flatten that out, I would get a long rectangle. What I'm going to do here first is figure out this top and the bottom circles. If I look at the graph, or on the x-axis, the radius is equal to 3. So that means area equals pi times 3 squared, which is equal to 9 pi. Same thing for this one, it's the same circle, so 9 pi for that one. Now if I think about what I did with this rectangle right here, since I unrolled the cylinder, I'm going to highlight this entire edge right here. Initially, that edge, if I were to circle it back up, it would be the circumference of this circle. So I'm going to trace this as red as well, because this red circle, when I flatten it, becomes this red straight line. And now this, I'm going to draw purple here, purple line is the same as this purple line right here, which is the height of the cylinder. So the height looks like it's 4 units long. So that means this is a 4, and the red line is the circle. And we use a circumference to figure out the length of this line. It's equal to 2 pi times the radius, 2 pi r, which is 2 pi times 3, which is 6 pi. So now the area of this rectangle will be 6 pi times 4 equals 24 pi. And now if I add up all 3 of the faces of the cylinder, 24 pi, 9 pi, and another 9 pi, the surface area ends up being 24 pi plus 9 pi plus 9 pi. 24 plus 9 is going to end up being 42 pi. There you go. Okay, so those are the examples for today. Go ahead and check Delta Math on Canvas and go ahead and get working on those problems. If you do have any questions, you can always email me anytime here, or you can message me on Canvas.